All right, so with 7D, here's 7D right here, and we're trying to solve for x. X is in the exponent position, so we're going to need to use logs. We're also going to need to use the laws of logs here. So let's take the log of both sides. So this is going to be a little bit of work, right? But we're taking the log of both sides here. So it looks like this. To the power of 2x minus 3. Okay. So if we take the log of both sides, we are starting down the path of getting that x out of the exponent position. Now, there's a little bit of an issue with this 4 here, and then multiplied by this, right? So what's the laws of logarithms that deals with products? Do you remember how I treat a product of a log? So log of a times b can be rewritten as what? Log of a plus log of b. Remember that? Okay, so this one is now log of 4 plus log of 7 to the power of x plus 2. See that? And then this is log of 9 to the power of 2x minus 3. Okay. So you with me so far? So we're separating these terms. We're using logs to separate them. And now keep an eye on the x terms, right? We kind of want to get the logs with the x terms together, or more importantly, we want to get the x terms combined and together if at all possible. So how do we get the x out of the exponent position? Power law, right? So the power law says this, and you're going to rewrite everything that you're not touching, but this is x plus 2 can now come down as a coefficient. So the exponent, or the power, can come down as a coefficient. So this is 2x minus 3 times log of 9. All right? So now we're getting close. Now x is a regular coefficient, regular number in a numerator. So now we can start to isolate for x. But what we have to do is we have to expand first. So log of 4 plus, this is going to be x log 7, right? Plus 2 log 7. When we just expand this, right? Over here we're going to have 2x log 9 minus 3 log 9. Okay? Now stop me if anything looks alien there. Are you following me here so far? Okay? The laws of logarithms. Okay? So now this is looking pretty good. Okay, I've got the x, as a coefficient with one term here, and an x as a coefficient with another term over here. So let's get the x's on the same side of the equation. Let's get everything else on the other side of the equation as best we can. So this is going to be looking like this. X log 7 minus 2x log 9. That's going to be on the same side. And we're going to pull everything else that was on the same side over to the other side. And we're going to switch the signs. So this is going to be, we're going to have, well, the negative 3 log 9 is going to be over there. We're also going to subtract log 4. And we're going to subtract 2 log 7. Okay? So yeah, this is a long question. Definitely is a long question. But as we get further into pre-calculus 30 here and into calculus, some of the questions are going to be a page long. That's just kind of the way it is. And as long as you can just put one foot in front of the other as far as these laws and keeping track of your signs and stuff, you'll be able to work your way through it. Okay? Just don't give up because it looks like it's a long question. That's all. Okay, so let's pull an x out. So we can take an x out here as a common factor, and now I have x just in one spot, and I'm left with log of 7 here, minus, now this is 2 log 9. I'm going to put this as log of 9 squared. Okay, so I'm going to take the x out. I'm going to put the 2 as an exponent, because that's using those laws, no problem. Over here, I'm also going to use this, okay, so the negative 3 here, right? When we have these negatives here, that's like dividing. But when we have a negative 3 here, okay, that negative 3 can come up as an exponent. Okay? So that's going to be log of 9 to the negative 3 minus log 4 minus, and we can just write this as log of 7 squared. If you want to do plus log 7 to the negative 2, that's okay too. It doesn't really matter. Okay? So we now have x equals, so all this over here is going to be, we're going to divide both sides, sorry, by log of 7 minus log of 81. Okay? So we're going to have log of 9 to the negative 3. That's fine to write like that. That's okay. Keep it like that. And minus log 4 minus log 49 divided by log of 7 minus log of 81. And like I said, you can do further laws of logarithms by showing these as divisions, right? You can write this as a single log up top and this one as a single log on the bottom. I don't think you really need to. I think you can go ahead and just evaluate this here now, and that should be your x value. So you don't need to do any more simplification. If you got x all by itself, just go ahead and let your calculator do the work. All right, so I'll give you a chance to evaluate that in your calculator to make sure we can do. Okay, so about 4.8477 or 4.85 approximately is your answer there. Okay, so again, you can just plug that into your calculator. You don't have to do any more simplification using the laws, but that's that. Okay, so 8.4 is basically all about using the laws of logarithms to solve for x. Remember, the log can pull the exponent down as a coefficient. That's the big thing, getting that x out of the exponent position. Okay, so 5c, if anyone wants to watch 5c here, this one does look a little tricky because there's only logs on one side, and when there's a log on one side, you kind of want to change that into an exponential function if you can, right? But maybe the problem is you've got two logs here. How you do this is, remember, these are logs are subtracted, right? So we can write this as a single logarithm, and it would be the log of, so base 2 of x divided by 3 equals 5. So you can write that as a single logarithm, and then you can change it into an exponential by going 2 to the power of 5 equals x over 3. Okay? So then you've got 32 equals x over 3. Then you've got 96 equals x. Okay? So write it as a single logarithm. That make sense?